Okay, welcome back to our video series on healthcare information technology. In this video, we'll discuss chapter number 4, Network IT Operations. Some objectives for this chapter: list and describe standard networking devices, explain the function of servers, explain how to set up basic networking, list the steps of troubleshooting a network, and describe different options for EHR and EMR network technologies. We'll start off with healthcare IT challenges and opportunities. The computer network is the foundation of computing technology in any office, but in particular in a healthcare setting. And network IT operations support electronic health records. And some topics that we'll discuss in this chapter: common network devices, network servers, setting up a network, troubleshooting a network, and the technologies used for electronic medical records and electronic health records. Standard network devices. And the International Organization of Standardization, or ISO, first released their reference model in 1978. And this describes how dissimilar computers can connect to one another via a network. And the model that was released in 1983 is the model that is still used today. And this model breaks networking into 7 different layers, and each layer contains a different networking task. Alright, this image, we have an illustration of that OSI model, going from level 1 to level 7. Layer 1 is the physical layer, layer 2, data link, 3, network, 4, transport, 5, session, 6, presentation, and 7, application. And on this table we have a more detail on each of the layers and what their functions are. For example, layer 1 is the physical layer. The job here is to send the signal to the network and receive the signal from the network. So this is involved with signaling and data transmission and reception. Layer 2 is a data link layer. This layer is responsible for dividing the data into packets. Layer 3, the network layer. This will pick the route the packet is to take and handles the addressing of the packets for its delivery. Layer 4, transport layer, responsible for ensuring that the data is error-free and given to the user. Layer 5, the session layer. This layer is responsible for allowing the devices to establish a connection between one another. Layer 6, the presentation layer, is concerned with how the data is represented and also formatted by the user. So compression, encryption, translation. And layer number 7, the application layer. This allows the have access to network services. Another standard network device is the Ethernet. It's the most common local area network technology, or the LAN. This will divide data into small units called packets. And the Ethernet is the network cable that plugs into the laptop or into the desktop, where the plug looks like a larger phone jack. And standard network devices are classified by what OSI layer at which they function. For example, hubs, these are older devices, and these are used to help connect multiple Ethernet devices on a network. These will typically use shielded twisted pair copper cables, or STP cables. And these devices work at the physical layer, or layer 1 of the OSI model. And these devices don't read the data that pass through them, and they're ignorant of the source or the destination of that data. Here's an illustration of how that would work. Here you have 3 desktop computers, all connected to one hub device. Now a network switch is a device that connects network segments together. And this has much more intelligence than a hub would. And this works at the layer 2 of the OSI model, the data link layer. And this will identify specific devices connected to its ports. And it can forward frames intended for a specific device or to all devices. And the hardware address, or the MAC address, the media access control, is used to identify each of those devices that's connected to that switch. And core switches can carry traffic between switches. And workgroup switches connect directly to a network device. And here's how all of this would work together in a real-world setting. Let's say you have a facility of 3 different floors. You have individual desktops on floor 1 and floor 2, floor 3. Each floor has its own workgroup switch. These workgroup switches are connected to a core switch, and that's connected to another core switch, which is connected to a workgroup switch. And from there, that workload is divided in between 3 different servers. Okay, another standard device is a router, and these operate at the layer 3 of the OSI model, that network layer. And these will forward packets across computer networks. And the steps that's involved here: it will read the destination address, and then it will send a packet to the next network towards destination. And this can filter out specific types of network traffic, which is a good security function. Domain controllers. A domain is a collection of devices that share a central directory database. A domain controller is a server that manages security-related elements on the network for the user. Servers. There are several different types of services and several different kinds of servers. and they all have different kinds of protocols that they use, and servers must be managed properly in order to be effective. For example, you can have a print service. This allows multiple users to share printers across the network. An example of this would be a standard office that has 3 or 4, say, desktop computers, all linked to one centrally located printer that they all share. File services allows users to share files from a central location. Application services, these are processes that run software for network clients. And communication services, this would include managing email, telephony, and instant messaging. So depending on what the needs are for that facility, they may have a server just for print services. They may have a server just for application services, or just for email and communication services in general. Server management. Some common tasks that are associated with managing servers include load balancing and allocating storage space. Load balancing is a way to evenly distribute the workload across a network. And there are some advantages to load balancing like this. This will reduce the probability of overloading a single server. It will optimize resources for the benefit of each network computer, and it's going to reduce network downtime. The hardware load balancer is also called a layer 4 to 7 router. This helps to balance out that load by the network. This is a physical unit that will direct computers to individual servers in the network. This is based on server processor utilization, number of connections to a server, and overall server performance. When it comes to managing storage on the server, this is an important task because of the large number of documents that have to be retained in a healthcare facility. So not just the documents themselves, but all the results of various diagnostic tests need to be stored. So PET scan images, CAT scan images, x-rays, all of those are electronically stored, so they are subject to a legal discovery if that patient is involved with a lawsuit, for example. So that is important data that must be controlled and must be stored properly. And that can lead you to storage virtualization, where you're able to store all that electronic data, but also hides the physical resources of the storage of the electronic data from the user. All right, next we'll talk about protocols. These are the rules for communication. This is essential for proper communication to take place between network devices. And there are 3 common protocols that are used. You have TCP/IP, which is Transmission and Control Protocol / Internet Protocol. You have wireless protocols, and RDP, Remote Desktop Protocols. For TCP/IP, there are several protocols that function together, and these function at layer 3 of the ISO model to provide addressing and routing of information. And TCP is the main transport layer protocol that establishes a connection between devices. Okay, here's a comparison between the standard OSI model and TCP/IP. For the OSI model, layers 1 through 7, and comparing that to TCP/IP, layer 1 would be hardware for the physical, and then network for layer 2, internet for layer 3, the host-to-host transport for layer 4, and then 5 through 7 would be all application. DNS, Domain Name System. This maps an IP address to its symbolic name, and the database is divided and distributed to many different internet servers. You also have DHCP, or Dynamic Host Configuration Protocol, and this assigns a dynamic IP address rather than a static one. So the DHCP server leases an IP address to a computer, but when that computer is off of that network, the IP address can be reassigned to another device. You also have a File Transfer Protocol, FTP. This is a method for transferring files across the internet, and this protocol will link servers to one another. And the methods for using FTP on a local host computer would be using the command prompt, or a web browser, or an FTP client application. You also have wireless protocols. These will enable mobile communication. In the standard that's used for the wireless local area network, or WLAN, is called IEEE 802.11, and the more advanced form of this protocol is IEEE 802.11n. And there's some advantages that the 802.11n has over the previous version. It transmits at a much higher speed. It offers a wider coverage area. It reduces interference, which also helps to improve security of that data being transmitted. And the last one we'll talk about is the RDP, Remote Desktop Protocol. This allows users to access another computer remotely over a network. And this will provide remote display and input capabilities over a network connection. It's designed to support different types of networks and protocols. So you're able to access a computer as if you were sitting right in front of it, but from a remote location. All right, now we'll talk about a basic network setup. This involves understanding connections to the network devices and configuring network hardware. and a variety of possible configurations exist. Some examples of client connections that could be used. One is the NIC card, or the Network Interface Card, also called the Client Network Adapter. And it's the hardware that's needed to send and receive data on a wired network. In this image here you see, this is what you would see on the back of the desktop case, and the network plug that would go into the jack here. And this is the actual NIC card itself that would be mounted to the motherboard. You can also use a wireless client network interface card adapter. It performs the same function as the wired NIC card, but there is no external RJ45 cable connection. And this uses an antenna, which may or may not be embedded into the adapter itself, and it may plug into a USB port directly. Some other hardware that could be used: a modem. This is a device that changes an analog signal to a digital signal. An internet modem, also called a broadband modem. This will connect computers and networks to the internet. A router connects with an Ethernet patch cable to the internet modem. This is generally pre-configured to act as a DHCP server, and it can also be configured to support port forwarding. The methods of communication between wireless clients can either be ad hoc mode or infrastructure mode. Wireless access point. This is used in an infrastructure mode, and this receives all wireless signals, and this serves as a bridge between the wired and wireless networks. In this image we have an example of an infrastructure mode with an access point. So here you have the wireless network of 3 laptops and a cell phone going to an access point with this router here. It's also connecting to this server and this desktop and then the internet also. So this access point here is serving the wired part of the facility and also the wireless part of the facility. Now the access point should be located near the middle of the coverage area. And regarding the security settings for the wireless network, you should turn on Wi-Fi Protected Access 2 or WPA2. You should disable Service Set Identifier, SSID. You should center the antenna placement. You should reduce power levels. And you should create the guest network. Alright, now we'll talk about network troubleshooting and regarding connectivity problems. Of course, first check that the network devices are receiving power. Use the command line utility ping to check for connectivity. If the message 100% packet loss, then the connectivity problem may be with the ISP, not any of your devices. Use trace RT to display route a packet travels, and this could show you where the transmission stops, where the problem may lie. And of course, make sure that the cables are not crimped or broken or torn loose from any connectors. Right, with interference, these are strong external signals that interfere with the signal being transmitted from the device. Fiber optic cables are immune to interference. Radio frequency interference, this is caused by broadcast signals from a TV transmitter or a radio transmitter. And electromagnetic interference could be caused by phones or radios, appliances, or lights. When it comes to wireless signal issues, there may be an issue with the wireless signal reaching its target due to the multiple paths that the signal must take to reach the receiver. And this is based on wave propagation. And a solution to a wireless network interference problem is you can either move the access point to a better location or moving the source of the interference. In this table we have some examples of wireless signal interference, such as absorption. Materials like concrete or wood or asphalt can absorb the radio frequency signal. Reflection. The signal is actually bounced back by large or by smooth objects, such as elevator shafts or walls or metal roofs. Scattering. The signal is bounced back by small objects or very rough surfaces, like rocks or foliage or sand. Refraction. The signal moves through different atmospheric conditions. So going from a bright sunshine to cold, damp air, the signal will be refracted, which will interfere with transmission. And diffraction, which is caused by an object that's in the path of the transmission, and the object has rough surfaces, such as automobile and tires. IP settings. Network problems can occur if the same IP address is assigned to more than one device. And if you think this may be an issue, you use the Windows command line utility ipconfig/all, and this will give you a list of all settings for the device. Alright, now we'll talk about network technologies for EHR and EMR, electronic health records, and electronic medical records. And there are 2 broad categories of decisions: cloud versus local network, and installed applications versus remote access. First we'll talk about cloud computing versus the local network. Some advantages for cloud computing. This can reduce hardware and software and personnel costs. You only are paying for the resources that you need at any given time, and the resources can be adjusted as the needs change for that facility. And a big disadvantage of cloud computing is that you have a separate entity that is responsible for managing the security and the privacy of those medical records. Now comparing installed applications versus remote access. For remote access, this can save time and money. A downside with remote access, not all applications run efficiently in a remote access setting, especially specialized healthcare applications. Okay, that brings us to the end of chapter number 4. A quick summary of what we discussed. The OSI reference model is a conceptual representation of how data moves through a computer network. Several different types of servers exist. Network load balancing helps to evenly distribute work across the network. Computer network protocols, these are rules for communication between network devices. Wireless local area networks are based on the IEEE standards 802.11 and 802.11n. Different types of network hardware perform different functions, such as the internet modem, router, wireless access point. And determining the most appropriate network technology for managing the EHRs and EMRs is not a simple, easy task. There are advantages and disadvantages to remote and local access configurations. So it really does depend on that specific facility, what their needs are, and what is best for them. Alright, that brings us to the end of this video on chapter number 4. We will continue our video series on healthcare information technology with our next video on chapter number 5, medical business operations.